Hello Titan Dev Team. Today we are going to be talking about nanite and triangle count. Now, to answer the question that's been popping up a lot on the Discord, how many triangles should my asset be? The answer is as many as you need to accurately represent the surface. Now, we've got some examples here. These are good representations of the surface, so they have enough triangle density in them that every element that is modeled is a good representation. It has a good silhouette. There's no low poly representation of that asset. A good area to look at for seeing where this has gone a little bit wrong is this asset here. You can see that we have the main problem that we're trying to avoid, and that is where we're not using enough geometry to represent a curved surface, which means that we end up with a slightly poorer silhouette. So you can see we have all these breaks here where we're using kind of straight pieces of geometry that are, kind of curved over time to try and represent that shape. So really we need to be putting in as much geometry as we need in order to get that good shape representation. Now, where this can go wrong is on an asset that is not working in a way that Nanite likes to work. Now, if you don't know how Nanite works, the basics are it imports your mesh in, it processes it, generates a ton of clusters and chunks, which are basically sections of your mesh at lots of different triangle densities, and then it loads in the one that you need based on how much of the screen that asset is taking up, and gives you a 1-to-1, or as close as it can give you, of triangles to pixels on the screen. And that means that you always have the best version of that asset as you go around, but you don't have any better than you need. And you can see where this is kind of broken on this particular asset. We're getting very little to no break on that geometry. You can see it's just not reducing at all, and that's because the asset has to have what's called a contiguous surface, which is a surface that is connected together. And things that stop that from being contiguous are geometry that literally aren't connected together, but also assets that have triangles that have different smoothing group information or no smoothing group information at all. And you can see on this asset we have very little to no smoothing groups on our asset. You can see each of these individual triangles. And if that is the case, then Nanite will treat each of these individual triangles as separate and therefore won't be able to compress them or reduce them down. There are some other things that it does as well. So it does this with UV seams and vertex color information as well. And there are a few other rules that it will keep to try and make sure it keeps the surface kind of represented accurately. But in general, these are kind of the main ones that you need to look out for. So when you're bringing in an asset like this one in particular is 7 million triangles, which for the size of the asset and all of the surface that it's trying to represent is not really that problematic. But unfortunately, where it's got no smoothing group information, it has absolutely no compression on it. The easiest way to check is to just go in close to your asset and see if you can see those triangles pointing out. You can also go to the Nanite fallback and you'll be able to see that it's very heavily triangulated on that surface. And you can also tell just by looking at the compression rate. And if your compression is very, very similar between the actual imported size and the Nanite disk, then it's going to most likely have not imported in correctly. So make sure that you've got your smoothing groups correctly imported in, and make sure that you're not using too many UV seams and things like that to kind of break up the geometry. Another thing to keep in mind as well is, again, as part of contiguous surfaces, something I'm seeing a lot of are things like roof tile, where they're individually modeled. Again, this gives the Nanite very little room to reduce down because all of these pieces are individual. It can't reduce that surface down any more than each of these individual tile sets. There's an example of this inside the base content folder. If you go to base content, level instances and Nanite structure. Here I've placed an example of a roof tile and I've built it in kind of 3 different ways. The first is using individually modeled roof tiles The second is importing in it as a displacement map, and then the third is displacing it inside a tool like Blender before importing it in manually. Now, the big thing you'll notice is that if we go into our nanite visualization and triangles, so we can see the three assets in action, you will see that the connected surfaces, so that's this one here and this one here, have a much better rate of reduction than on this surface here. So as we zoom out, you'll see that these surfaces do a significantly better job of reducing down triangle density, whereas this can never really get to that point because it always has to try and keep all of these individual meshes as a represented element. The other drawback to having these individually modeled is that we have very little space to go on our low level representation. So when we fall back to a non-nanite representation on a platform like mobile or Switch, you can see that as we have our models here, it's okay at this kind of like highest possible level, but as soon as we go out to a LOD level, we start losing the actual surface because we don't have good representation. Whereas if we use our nice, kind of tessellated plane, as we zoom out, and again, I've shifted the LOD level here just so you can see it a bit more clearly. As we shift that out, you can see that we keep that plane representation. So even though it doesn't look very good, it looks significantly better than this very wholly asset that we have here. You can take a look at any of these assets and see how they're built. One thing to consider is just your edging, that you might need to go in and put custom geometry on the edges of the surface. But if you can keep this as a contiguous piece of geometry, you'll have a much better time and build a much better performant asset. Just to go over a few other assets that have some good examples, we have this one here. This is reasonable from a mesh standpoint because the geometry is at least connected together. So it looks like it's been maybe voxelized or something like that, and then they've cut out the interior. However, they've got all of these holes in, which actually they'd be much better off just closing those off. One, because again, it keeps it as a nice contiguous piece and it's got more geometry to reduce around, but also because you haven't got anything on the inside anyway. So to have these holes in there isn't really going to help you that much. The main thing that is worth pointing out with this though is that while this looks good on the surface, if you take a look at the unwrap, you can see immediately that they've kind of done what looks like an automatic UV unwrap on this particular asset. And for something like this, where it's literally just a cylinder, they'd be much better off having this as a tiling texture and then displacing it, which would give them the exact same look, if not a little bit better, at a fraction of the texture resolution that they're needing to use because of this particular unwrap on here. So worth keeping in mind. They've got this asset in here as well. This might be the same person, might be slightly different. One thing to try and avoid is having geometry kind of layered next to one another. This is really difficult for culling, so we can't reduce this geometry as much. If the geometry isn't visible at any point, then it really shouldn't be there because again, it's wasted and unnecessary. Again, this happens on a similar asset over here, so you can kind of see that as I go into this surface, it never really shows me an interior because it's always kind of like got other bricks that are still very visible. So for this particular element, what you should do is, if it's a unique piece, is I would create a low poly representation around this, shrink wrap it, unwrap it, and then use that instead as the mesh and just project that data onto. If you need an extra video on how to go about doing that, I'd be happy to put one together. And then these are some good examples as well of where it's kind of gone a little bit wrong. So again, this is just a low poly asset, but kind of it's 204 triangles, but it doesn't really represent the surface in any real way. So the texture detail that's on here, indicates that this should be really rough and broken up and, kind of chipped and worn. But there's really none of that information on the actual surface. So it very much looks like it's just a texture that's been placed on a rectangle rather than it actually looking like a proper wood beam. The kind of the opposite problem, or not necessarily opposite, but a similar problem with this one. Again, this one is actually much more heavily subdivided. So whereas the other one was 200 triangles, this one is 212,000 triangles. So again, this is bad representation of the silhouette for the geometry that they've put into it. They also haven't actually turned nanite on this asset, which is again an easy thing to forget, but it's not a good idea to not have that. So for this kind of thing, you've got too much small information that's really not adding to the silhouette, and you've done it on a very basic shape. So if we look out to to here, this is just a rectangle with a kink in it, whereas actually you really want to try and get some better shape representation on this asset, and that's where you should be putting your nanite geometry. If you are just going to have it as a rectangle, there's really no point in subdividing it and subdividing it and subdividing it if you're not going to actually use that geometry. My guess here is that this person did a subdivision, but they used simple, so it didn't actually modify this rectangle with a kink in, and then they just sculpted on top of it. But really they should have subdivided and actually sculpted the whole thing as they went, rather than using a simple representation, because you can very clearly see this is still just a cube. So hopefully that's helpful, and if you have any more questions, feel free to reach out on the Discord.